Welcome back to R for Economics. In this video, we're going to be talking about the H2O for Deep Learning package. More information is available at this website. First, we install our package, and this ML bench is being brought in as a source for the data that we're going to be using, and there's a summary of the data. So this has to do with benign or malignant cancer cells during tests, and then properties of those cells. So for this type of action, it's actually using the local host, your computer, in order to get more CPUs at the same time. So we need to open up a connection, and it starts running. As we can see, it starts running, and it tells you how many clusters, how many cores you're going to be using, and this is just used to accelerate the model and how it estimates. Now, there are requirements for the input. You can see that breast cancer right now is a data frame, and what I need to do is, if we look at breast cancer, you see that it has these ordered factors, and I need to convert those to factors. So I'm just going to do that in a separate little routine. And then if I look at the summary now, and if I look at my BC1, which is a copy, and then the factors have been changed. So ordered factors don't work, but factors do. And this won't affect our overall results. We're going to have the training and test set being the same. We're going to set Y and X to be training 11 will be the Y, test will be everything else, because 11 is the class of benign or malignant. We're going to set those as factors. And then we're going to run our deep learning. So H2O deep learning is the function, and X is equal to X, Y is equal to Y. Now these could be clearly different, equal to something else. Data frame, multinomial distribution. Here our activation, everything is going to be rectifier without dropout, but we could actually set that up as different ones, and also set them up to be a layer of rectified linear units, and then logistic, and so on. And we can change how the hidden layer is set out. And then dropping in epochs and the weights and biases. So we'll just run this. This will take not that long. And we should have a model. So here we have our model results that come through. It gives information all through, like the root mean squared error, the predicted, and then you could use this to predict a series if you wanted to. You can look at the importance. So what's the most important? Cell shape, cell size, bare nuclei, and you can see that the relative importance is dropping. We can look at a plot of these using the H2O var imp plot. That's the variable importance plot function. And then we can just do the top 10 of these, let's say. And we can see which ones are the most important. And you can see how they drop down. Here we can get them in the order that we brought them in. And this will give us our weights of which weights are the highest for each of these. Now, for these types of things, you need to close the connection. We open the connection here, and we have to make sure that we close the connection here. So we're going to close the connection. Are you sure you want to? Yes. So now we've done our H2O version. There are many different options you can choose for the deep learning function. And H2O is a more general package. It also has random forests in it. It has decision trees. It has some other models also included inside of the total package. So this is a large package which encompasses a lot of the other machine learning techniques. A second one for that is Keras. Now, Keras here is coded in R, and you can install the package and look at the library. But what it does is it takes your R code that you have here and converts it to run in Python. So Python is required for this as an external, so you have to have it installed, either Anaconda or Microconda, one of the condas, in order to have it run. Okay, and then once you get to the data and the estimation steps are very similar to what we saw in H2O. Great, and we'll see you in the next video.